Hey guys, so today we're going to be talking about diffusion. So diffusion is another phenomena that can be associated with any state of matter, solid, liquid or gas. To define diffusion, it is simply how one state of matter mixes with another. It's simply mixing, right? For example, if you use a deodorant, you'll notice that the smell comes in the whole room or the whole house whenever you spray it, right? So that is because the gas diffuses, which is basically mixes with the air that is around you. So to look at our activity now, what I'm going to do, I'm going to take a solid, this is this chemical potassium permanganate, and a liquid which is water. So for this activity, I'm going to take a little amount of solid in a spoon. So if you look at potassium permanganate, it's this bright purple colored solid. So I'm going to try to witness how a solid diffuses into a liquid. So to do that, I want you to watch the liquid carefully. When I add the solid, you will see that. You'll notice that it is starting to spread throughout the water. And now the water takes the purple color of the solid. Right? If you stir it a bit, it is going to mix. So I know for sure that solids can diffuse into liquids. Now I want to look at whether a liquid is going to diffuse into a liquid. For that, I'm going to take this solution that we made just now, that is potassium permanganate solution, and I'm going to take some plain water. So I'm going to add this liquid to this liquid to see if they diffuse or not. So I want you to watch this colorless water carefully when I pour this in it. As you see, the liquid is starting to spread in this. If I add more, you'll see more of this liquid just spreading in, and it will start to take a light purple color. It's not as dark because a lot of it is water, so it is a very mild purple color. The more I add, the more dark it's going to get. So this is also proof that liquids can also diffuse in other liquids. Okay, so now we are going to talk about the third property of any state of matter, and that is compression. Now, compression might be a new word for you, so you might be a little confused, but there's no need to be afraid of it. It's a very simple word. I've written it down here. Right? To understand this word, I'll just look at the center of it. I'll see that the word press is written in between, right? So compression is in a way just pressing an object. Am I able to press this object and change it in some way? That is all compression talks about, right? So compression is simply trying to press an object to see if it changes. three states of matter: solids, liquids and gases. I'm going to check whether each of these states of matter can be compressed or not through a very simple activity, right? So for this activity, I'm going to need a syringe, and I'm also going to need every single state of matter that we have: one solid, one liquid and one gas. I'm using a salt for a solid. I'll also be talking about this marker. I'm using water for liquid, and for gas I'm going to use the air that is around us, right? Okay, so first I'm going to start with gas. I'm going to try to see if I can compress a gas, and this will be the tool I use for it. It's a simple syringe of 5 ml capacity, right? So whenever I fill the syringe completely, it will hold 5 ml of gas or liquid or solid, anything, right? So what I'm going to do, first thing is, right now it says 0 ml, right? So that means there is no space or nothing inside the syringe. I'm going to slowly open it up all the way till it reads 5 ml. Now there is 5 ml of air present inside of my syringe. I'm going to try to press this 5 ml of air. So the way I'm going to press is, first I'm going to close this opening over here. Now if you see, there is nowhere for the air to escape. It can't go out from here, it can't go out from there. But I'm still going to try to press it, and I want you to keep noting the markings, right? So I'm going to start with 5 ml of air, and I'm going to keep compressing it, right? It is easy to go from 5 ml to now I'm seeing already at 4 ml, right? The air that's there in 5, I am able to put it in just 4 ml of space. I'm going to go a little more further. Now I'm at 3 ml of space, right? I have reduced it from all the way 5 ml to 3 ml. I'm starting to feel some push, right? My fingers are being pushed by the gas. Now I'm going to go further, right? Now if you see, I'm struggling a bit because there's a lot of resistance from the gas. I'm trying to pressure it a bit too much. So now I've compressed all that gas in just 2 ml of space, and it's quite hurtful. My fingers are hurting quite a bit. Finally I'm going to try to go as far as I can before my fingers just can't handle that. It's 1.5 ml. Right, so there's a big dent on my finger. That's because of the amount of pressure that was being built, right? So we saw that very easily I could compress so much, 5 ml of air in just 1.5 ml, roughly ml and a half of space, right? This much gas could easily be pressed into this much of space. With machines it's much more easier, right? So I know for a fact now that gases are what I can say highly compressible. Means I can compress them easily, and I can compress a lot of gas in a very small amount of space, right? Now the next, I'm going to test liquid. For liquid, I'm taking this syringe. I'm going to draw some liquid into this syringe, some water into this syringe, right? Now my syringe is about full. There's about 5 ml of water in my syringe. I'm going to repeat the same process. I will put my finger on the opening, and I'm going to try to compress it. You'll see that no matter how much I try, it's still at the same place, right? There may be very little bit of movement, but other than that, there's nothing. You can try this at home. See, my fingers still hurt, but the liquid is not at all allowing me to compress it, right? So liquids are mostly what we say incompressible, means they cannot be compressed. So there are very few liquids that can be compressed, but to a very little extent. So for liquids we will say slightly compressible or not compressible, meaning the liquids that can be compressed very little, the other liquids cannot be compressed at all, Now finally coming to solids. Now my marker here is a solid. I can easily say that I'm trying to compress it between my hands, but you'll notice that no matter how much I compress, short of breaking, nothing is going to happen to the marker. The shape does not change, as in the volume also will not change for the marker. Another way I can demonstrate is with the help of this salt. So I'm going to take this syringe here, I'm going to pour some salt into it. Right? I'm going to try to compress this fine grainy salt. It is not a big solid, which is a small solid, but ultimately still a solid. So we will try to compress this grainy solid into a solid, right? So if I look at it now, there's a little over, there's about a little over 3 ml of salt over here. I'm going to push back the syringe in this, right? I'm going to push it back. I'm going to make sure I remove all the air from here. I'll push the syringe all the way up until there is no air remaining. It's just about 3 ml of salt. Now I'm going to try to compress this salt again in the same way. Now salt, again being a solid just like my marker, cannot be compressed. No matter how much I press, it is not going to be compressed at all. Right? Now it's a very simple activity that you can try at home. Now I also know finally that solids cannot be compressed. So I will say solids are simply not compressible.